Assalamu alaikum wa rahmatullah. Bismillah ar-Rahman ar-Rahim. Today is our class. We are going to continue what we have started before. So last time we stopped here on this slide after we taken the what they call it nested queries. So we learned how to use the subqueries in the where clause, in the select clause, and also how to use multiple subqueries inside the same main query. Do you have any question in this regard before we start? So as I mentioned, the subquery should be run first, then the result of the subquery should be passed to the main query in order for it to get finished. Okay? Then we stop here. Combining subqueries, I think we already explained this slide. This slide shows how we can use multiple subqueries in the where clause or even in the select clause. So here we can use the subquery at the right side of the operator at the where clause. So if let's say we use this operator greater than or less than or equal or whatever, then we have to put the subquery on the right side. Cannot be used at the left side. Even it works, but it's not good practice to put it at the left side. Okay. Also, we can use it with and, with or, everything. I think I already explained this, right? Guys, I explained this before, right? Is it clear or not?
Yes, sir. Clear.
Clear. So we continue to the next slide.
Sure.
Yeah. We even learned how to make nested subqueries, maybe one main query inside it, one subquery inside the subquery, another subquery. And also I give you some examples, right? Here, show all customers who have placed an order. So in this case, we have to check what customers had already an order before. So in this case, we have to write a subquery to get the customer IDs who had orders. Okay, so in here they write select distinct customer ID. Why distinct? Because in many cases the same customer will have multiple orders, right? So instead of retrieving the same order customer ID many times, we filtered it to retrieve a unique list of customer IDs. Okay, so in here we need to retrieve every customer ID who had orders only one time from order table. Okay, so in this case we will retrieve list of customer IDs. So that list could include one, could include more than one customer IDs, and also could retrieve no one, right? It could be an empty list, but in all cases it's still a list, right? So the compatible operator with the list is n, the n operator. Okay, so here we want to check select customer name from customer customer table, where customer ID in this subquery, the set which is retrieved by the subquery. Okay, so this is how we can retrieve the customers who have placed orders. Okay, as I mentioned before, the subquery is embedded in parentheses. It must be written between two parentheses, and in this case it returns a list that will be used in the where clause of the outer query. Outer query means the main query. Okay. So here we have this example, Sally Pet Store. So if you are interested, you just go through, try to understand how they design the tables and how they link them together, and try to get new ideas. And for sure, all ideas available here in this diagram have been given to you. I have explained all ideas, every single idea. Okay. Subquery for calculation. Which cats sold for more than the average sale price of cats? So here, before you find which cat has been sold for more than the average sale price of cats, in order to get that, you have to calculate first the average sale price of cats. This is the subquery. So you have to calculate this first. Then after that, you have to plug it into another query to retrieve the list of cats that have been sold for more than the average sale price of cats. So assume we know the average price is 170. Suppose that we know the average, okay? So maybe we know because we run a query to calculate the to calculate the average of the cat prices, okay? Then we got this result, 170. So in this case, the query will become like this. So we will use this one, this average here as a number, right? So here we can see, select sales animal.animal ID, animal.category, sales animal.sale price, then from animal. Until now it's clear, right? Is it clear or not?
Yes, doctor.
Yes.
Yeah, then we have this from animal, then sale animal on this one. We in this query, I think they missed the join, right? They missed the join keyword. Okay, join sales animal on animal.animal ID. Okay, guys, remember when I correct something in the slide here, it's not corrected in the Bootstrap because in Bootstrap we already uploaded the slides with the mistake. So if I corrected here and you have downloaded that slide, please go and correct it in your slide, in your copy. Okay. So here, this one is to join these two tables, animal, that includes the information of animals, and sale animal that includes the sales for that animal. Okay. So here we have these two tables joined. Then we have displayed some fields from the second table, the sale animal ID, and the animal category, and also sale animal price, sale price. Then here where join with this on this condition, where the animal ID from animal is equal to the animal ID from the sale animal. Okay, so here we link the two tables together using the join on. Where here now we want to do filtration. So filtration, what they call it? We have selection and projection, right? Projection is to select the columns here. We already have done the projection, but now we want to do selection. We want to select some records. So here, in this case, we want to select only the records that's related to cats. We don't want to select records that's related to, for example, dogs, fish, hamster, whatever. We need only cats, okay? And also we need the sale animal.sale price to be greater than 170, which is the average of the price, okay? So in this case, the result will be will satisfy our requirements. So here, after that, if let's say we don't want to rely on the pre-calculation that we have done to get the average sale, so in this case, we have to embed the subquery here that calculates the average sale for cats inside the main query. Instead of this 170, we have to open two braces. So here, two braces like this, two braces for the sub-query. So I will break it into multiple lines to make you and to allow you understand it. So like that. It was like this. At the beginning, it was like this. Greater than 170. And here we have to put, instead of the 170 that we pre-calculated before we write this query, then here we have to put the, what they call it, the query itself, the sub-query itself. So the sub-query itself is like this, okay, as you can see here. Select average sale price from animal join sale animal on animal.animal ID equal sale animal.animal ID, where animal category is equal to cat. Why we need to join? Because here we want to retrieve the sale price, and also together we want to retrieve the category. Category comes from the animal table, and the sale price is coming from the animal sale, right? So that's why we have to combine to join these two tables, the animal and sale animal. Okay, so this subquery will retrieve one value, only one value, because here we used average, right? So average takes many records and retrieves only one value, because this average function is called, what they call it, multi-row function. Multi-row function. So multi-row function takes multiple rows, returns only one value. Okay, so we take this, we put it instead of the 170 to get this query. Okay, so this query actually is going to run and retrieve the entire result as intended. Okay, is there any question?
Doctor,
Yes.
the top select is different from the bottom, right? The bottom is if we did not know the average price, right?
Yeah, if we don't want to pre-calculate, the average, as we have done here, because here we assume that we know the average price is 170. So how we know? That means we pre-calculated, right? But if we don't know the average price, and the average price actually is going to be changed whenever we sell a new cat, right? When we sell a new cat, the average price will be affected every time. So it's still dynamic, right? So in order to keep it dynamic, we have to write the subquery instead of fixing the value. Because if suppose that we yesterday calculated the average price and we found it 170, but because today we sold two cats for like 10 ringgit each, in this case the average price is going to be affected. So maybe it will become like 150 or 140, right? So if we still using the average price of yesterday, the result will not be correct. Okay, clear?
Clear.
Yeah. Any question, guys, before I go?
Doctor,
Yes.
is it case sensitive? Because I see the word join is caps and that one is not caps.
It's not sensitive. It's not case sensitive. You can write it anyway. Small, capital, all capital, capitalized, whatever. It works.
Oh, okay. Thank you.
Yeah, no problem. Okay, any question regarding the subqueries and the join?
No.
Okay. If no, that means we are going to move to this topic here, using not in with a subquery. Actually, not in is very easy. It's the opposite of using in, right? Nothing new. So if you know how to use the in, you're supposed to know how to use not in. Okay? So here, which animals have not been sold? So start with list of all animals at first. then subtract out list of those who were sold. So how we are going to do that? I think all of you knows about this, right? The subtraction, the union, the intersect, right?
Yes.
Yes, this concept actually is or commonly applied here in the SQL. Okay, so especially when we deal with the in and not in. Okay, so here at the first, we required to find which animals has not been sold. Okay, so in this case, we have to find the list of all animals, right? All animals. Then we supposed to find the animals, the list of the animals that have been sold before, right? So actually this list is here, is available here, right? So this one is sold inside, because this one is the entire group of animals, right? Including the sold and non-sold. Is that clear, guys?
Yes.
So if we take this group, and we minus this group, we subtract this group, then what we will have? We will have this area, right? The animals that has been not sold before. Okay? Is that clear? So how we can make this? We select, we first find the list of all animals, then we subtract out list of those who have been sold. So the first thing we write, select animal, animal ID, animal name, animal category from animal. So this one is the entire list. Okay, so this one includes all animals, but here we have where clause, right? So that where clause actually here will retrieve the list of animals that have been sold. So in this case, what we retrieve, so the condition is the animal.animal ID not in. Here is the subquery, select animal ID from sale animal. So it's better if we write this thing. It will be better, okay? Because here all animal ID actually is going to be retrieved, even it could be retrieved multiple times, right? That's why we better use distinct in order to retrieve unique list. Okay, unique list of animal ID. So here we retrieve the entire list of all animals, then we subtract here the animals that have been sold. So how we detect that the animals have been sold? So the animals that their animal ID is available in the sales animal, that means they have been sold before. Okay, so here this list of the subquery will retrieve the IDs of animals that have been sold before. Okay, is that clear?
Yes, yes.
Okay. Now here we have another topic called union, intersect, minus. Okay, so union actually, if let's say we have a group of A and group of C here, T1 and T1 and T2, sorry, group is called T1 and the other group called T2, and here if let's say we union them together, we use union to attach or to combine these two groups together. In this case, the result will give us A plus B plus C. So the entire area of the two groups, right? But if we want to calculate the intersect between the T1 and T2, the intersect here will be the group of B, right? Which is at the overlapped area, right? Here the minus minus area, if let's say we take T1 minus T2, it will give us only A. Okay, only A, because T2 is already subtracted. So only the remaining items will be the A area, right? Okay, as you can see here, T1 union T2, it will give A plus B plus C. T1 intersect T2, it will give B, this area only. T1 except T2 will give A. Is that clear, guys? It's very basic concept, right?
Yes.
Okay, what if we say T2 except T1? What is the result?
C.
B.
C.
T2
C.
T2 except T1. It will be
C.
C, right? Because we have T2 and we remove from the T2 T1, right? So all of this area of T1 is going to be excluded, will be removed, right? So the remaining will be only the C area. Okay? So here, list the name of any employee who has worked for both the East and West regions. Stop. Sorry for that. Okay. List the name of any employee who has worked for both the East and West regions. Okay. Actually, this kind of explaining on the slide is not that good, but I'm going to finish these slides this way because from today onward, I mean, after we finish this slide, we are going to go through the slide, go through the SQL practices and try to implement them and see how they are working and so on. Okay, so we will start with the real commands with the database, like what we have done before. Okay, so here the query is like that: select EID, which is the employee ID, and name from employee ist, intersect, select EID name from employee ist. So suppose that we have two tables. The first table is called employee ist, and the second table is called employee ist. So if we run two selects to retrieve all employees from the east and west, then we intersect them, we will get the result of the B area, right? The overlapped area. So in this overlapped area, we will have the employee who worked in both sides at the west and east, right?
Yes.
Yes. So it's very easy. So here we have a complete query, normal query, and here we have another query. In between, we can use union, we can use intersect, we can use also except. Okay? Very easy, very simple. So it's like that to simplify the things. Very slow, huh? Okay, if let's say we select star from faculty members. Okay, suppose that we want to retrieve employees who are working in the, what they call it, the network department, plus employees who are working in the multimedia department. So here we can easily say like this, where department is equal to, like that, CS, sorry, computer networks. Then another query here. This one is MM, right? So this one will retrieve the computer network department employee only, and here will retrieve the multimedia employees, right? But if we use union at the middle here, and we remove that semicolon, so this becomes only one query, right? So in this case here, if we run, it will give us only computer network and multimedia, because the result of the first query, the result of the first query and the result of the second query actually is going to be combined together in one list. Definitely it could be run easily, right? I mean, it could be written in different way. It could be like this, in, for example, but I wanted only to explain to you how it works. Okay, so we easily can write that like this. Okay, so this will retrieve the same result, right? But in order to show you how we are going to use the union, you see it's the same result using a very short command compared to the previous one. But in order to show you how it works, so we have to use very simple scenarios. Okay, so here, if let's say if let's say let us find another scenario. Let us find another scenario to make it a little bit complicated. Select star from rooms. We have rooms from 1 to 6, and here we have employees. Room number 4, room number 5. Okay, suppose that we want to find who is working in the office number 4 from the computer science department. Okay, because as you can see here, in office number 4, we have one computer science, one multimedia, another one multimedia. So in this case, what we want to do is to select members, all members who are in the office number 4, right? Office ID equal to 4. This is the first query, right? So we got 3 people. Then we want to exclude all people who are not from the computer science, where their department is not computer science. Okay, so this will give us the two guys from the multimedia, right? Okay, two guys from multimedia and the two guys from the computer science. So in this case, if we use except here, what we are going to get? What happened? Except. Yes, correct. Okay, what we are going to get here? We are going to get the I mean the what they call it here when we use the intersect. Sorry, the except. We will minus the second group from the first group. Okay, so here the result actually is going to retrieve only the guy from the computer science in the office number 4. Okay, what happened? What's this? Command not properly ended. I don't know what's wrong with it. Line 2, column number 1. Office ID. Is the office ID is this. I think the office ID is like this. It's a string, I think, if I'm not mistaken. So in this case, still has an error. Let's see. Office ID is number. Okay, what's wrong with that? This one, it works very. Oh, should we write it like this? I don't think, but this one is really an ununderstandable error. Close line 1, column 51. Column 51 is this. Okay, let us use union to see the syntax. Is it correct or not? Union is working. Okay, what happened? Why except is not working? Syntax error, partially recognized rules, railroad diagrams, order by cause equal to order. What is this? Nothing related to the except. I think maybe the except is no more available. exc ept. Yes, correct. exc ept. Yeah, correct. I don't know why it doesn't work. exc. Okay, let us see what happened to the except. Except Oracle. SQL except keyword in Oracle. I'm trying to use except keyword in Oracle 10, but kept getting error. Unknown command. Yeah. You see, there's something I think they introduce different thing. They introduce minus, I think. Okay, here he uses the same thing. Okay, so here is my query. I'm finding the name of students who enrolled in blah blah blah. So he uses minus. Okay, minus could work, except all. If you want here, or activity will support except. So okay, only some versions could support the except. Okay, for our case, we try to use minus. So minus, is it like this? Minus, yeah, like this. It's supposed to work. Okay, it retrieves only one person. Okay, let us take the thing step by step. So the result of the first query here, actually is going to retrieve what? This guy, ID number 7. Okay, I'm going to take print screen here. I will put it here to explain to you how it works. Print screen. This is the first group. Okay, then we need to create another file here. Okay, let us take the result of the second group here. Okay, another print screen. We put it here. Let us take this part only. We put it beside this. Okay, so here we used at the middle here, we used minus, right? Okay, how the minus works? Actually, it's going to exclude every item available in the first group and available in the second group. So here, let us check Ziyad. Ziyad is not available in the second group, so it will remain. What's about Salim? Salim is available, so just remove this. Okay, then what's about Muhammad? Muhammad Khalid is also available in the second group, so we are going to exclude it. So the result is going to be 7 Ziyad Muhammad, right? Okay, let us run this. Ziyad Muhammad. Okay, what if we use intersect, the other concept, the intersect, this one. Intersect actually is to find what? To find the overlapped area. So it will find the people available in the two groups, right? The people available, intersect. Intersect means intersection. Okay, so here, if let us go here. What are the people who are available in the two groups? Okay, let us check. Ziyad is not available in the second group, so that one is going to be excluded. Okay, we are going to exclude Ziyad. What's about Salim? Salim is available in the two groups. Okay, it will remain. Muhammad Khalid is available in the two group. It will be remaining. What's about the Ahmed Ali? Ahmed Ali is not available there. It's going to be removed. And here, Salim is available, Muhammad is available, and Noor is not available. Okay, so here the two names only are going to be retrieved. So Salim, Amina Salim and Khalid Muhammad, right? So okay, let us run here. Amina Salim and Khalid Muhammad, right? So everything is as we intended, right? Okay, what if we run the union? Union actually is going to combine the two groups together. Okay, let us come here. How many items here we have? we have 3 items at the first and 4 items at the second, right? There are intersected items, am I right? But even though there are some repeated faculty members here in the 2 groups, all of them are going to be retrieved. So the result, if we use union here at the middle, if we put union, then the result will become 7 records. Okay, let us use the union and see how it works. So the result is the 7 records, but here, as you can see, the repeated items are only shown 1 time. Okay, so here, if we come here, how is the result? The result is this, and this, and this. Then we take the second group. This one is not available there, so it's going to be displayed. Salim is available, so it's going to be excluded. Then Muhammad Khalid is available, before it's going to be excluded here because it's already in the first group, right? So here, what's about Muhammad Noor? Muhammad Noor is not there, so the result will be 1, 2, 3, 4, 5 records. Okay, let us confirm. 1, 2, 3, 4, 5 records. Okay, correct, guys? Is that correct, guys, or not?
Yes.
Okay, you understand the concept?
Yeah, doctor.
Yeah. One more thing I want to show you. When we deal with the union, it's very easy to get to fall into errors, to create some mistakes. That mistakes could be like retrieving first name, for example, first name from the faculty members, okay, like this, and maybe retrieving the room style from rooms, like this. Okay, so this one, the first query will retrieve us list of names, right? The second query also will retrieve us list of names, but these names are for styles, right? So if we combine them together, works, right? It combines people names together with the room styles. So it works, but it's meaningless, right? So be careful. When you deal with the union and other things, it's easy to combine things that's not homogeneous. Okay, you have to combine only the things that's from the same type. Okay, don't do mistakes like that. Okay, so that's all about it. Is there any question?
No, doctor.
Yeah. Okay. This one need to be corrected actually, because here they wrote minus and here they still keep except minus. Okay. Then union here is already explained, and let us check here if there is any comments need to be taken into account. Yes, here columns in the 2 select lines must match the columns, the column number and the column type. Yeah, this is very common mistake. So if, let's say, even if you deal with the same thing with the same table here, so if, let's say, you retrieve only the first name and the department here, department from the first query, okay, it run first name and department. Then the second query here, maybe we mistakenly we retrieve the for example department, is it? Oh, department is also string. So I want to find something which is number. Number is office ID. office ID. Okay. So here we retrieve three records, three fields. Okay. So if we retrieve three fields and from the first query and from the second query we retrieve only one field, so here the two queries are not compatible. You see, two queries are not compatible, so they cannot be combined together. Okay. So here you see query block has incorrect number of result columns. Query block has incorrect number of result columns again. Yeah, so the problem is to use compatible number of columns. Okay, so what if we put office ID and department in the wrong order, like that? Okay, so in this case we are going to get another error. So now the error is that the result that comes from the department actually is supposed to be combined with the result that comes from the office ID, right? So this one is a string and this one is an integer. These two types are incompatible, and also these two types are incompatible. Okay, so here if you see the error, expression must have same data type as corresponding expression. Okay, so this one is the expression and this is the corresponding expression. So everything here should be in line. So the same number of columns and the same sequence or the same order of columns. Okay? Is that clear, guys?
Yes, doctor.
Okay. Need to search data from the tables. Okay. This is the important things that we have to take into our account. So here we came to the summary. In this chapter, you learned how to define key terms like join, equijoin, self-join, non-equijoin, natural join, outer join, set operators, and subqueries. And also you learn how to apply the DML command to insert, update, and delete data from table, and how to write single and multiple table queries using SQL commands, and also how to write queries using subqueries. Okay, we had learned all of this together. If you have any question, please let me know before I close this presentation, because we are going to take another thing if you don't have a question. No questions? Okay, it's up to you. If there is no questions, I'm going to leave this presentation and I'm going to go to other part. Actually, the other part is what they call it lab practice. Okay, lab practice here we have from 1 to 8 lab practices. I don't know what is this. Actually, as I said, all of this are given by the course coordinator. So this one shows the structure of the database that we should work on in this course. So the structure of the database here, we have countries table that includes name, country ID, country name, and foreign ID, the region ID, sorry. Then after that, we have what they call it department, and department table includes the department ID, department name, manager ID, location ID, and so on. Then we have employees table that includes the employee ID, first name, last name, email, phone number, hire date, job ID, salary, commission, BCT, manager ID, and department ID. Also, we have jobs table that has job title and ID, also minimum salary and maximum salary. Then we have job grades. Here we have grade level, grade lowest salary, highest salary, and also we have job history, which includes the employee ID, start date, end date, job ID, department ID. This will include the history of every employee. So maybe the same person works in many places in different departments. So maybe one year in the department A and 2 years in department B. Everything here is going to be saved in the job history. Also, we have something called locations. Locations will include location ID, street address, postal code, city, state, province, and country ID. Then we have region ID, region name. That's all. This is all tables that we should have in our database. So in order to prepare that, actually I ran the query last time, but it shows some errors. And let us try to fix that errors. Oh, I think the local one is very slow as well. Okay, do you remember how to delete tables from database? The delete command of the table. Do you remember that? It looks like I'm talking to myself.
Yes, I remember that.
So what command is that?
Delete.
Remove.
Remove.
Drop.
Yes, correct. Drop. Who said drop?
Viral.
Khairul.
Anonymous.
Anonymous. Okay, that's good. Drop is to delete objects from database. Objects from database could be table, could be relation, could be index, could be primary key, could be whatever. Okay, so in order to delete objects that could be displayed on the left side tree here, you have to use the drop command. But in case you want to delete data, so in that case you need to use the delete command. Okay, don't mix up the things. So here, if let's say we want to delete the countries table or the region table, for example, so in this case we have to say drop table region, like that. Okay, but this one actually is going to show an error because the region table is used as a foreign key in other tables. So drop table regions error, unique primary keys in table referenced by foreign keys, blah 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 in other tables. Okay, so we cannot delete it. This is what we call the dependency. So there are many tables dependent on this table. That's why in order to delete this table, we have to delete every dependent table on this one. Otherwise, we will not be able to delete it. Okay? Is that clear? So what if we want to use to delete the job history? Job underscore history. Let us check before we delete. What's the columns here? This one is a foreign key from employee ID. This one is local variable, local field. This one is a foreign key from other table. This one is a foreign key from other table. So here I think this table is low level. That's why it could be deleted because nobody is dependent on this table. Okay, let us try. It will be deleted. Yeah, table job history has been deleted. Okay, What's about the other tables? This one, let us try, because I want to delete all of these tables in order to create them again. Has been dropped. Department I think is independent table has been dropped. Countries is based on, no, we have to delete the employee first in order to get that one deleted. So this one uses the country ID, location ID, and so on. This one also cannot be deleted now, I think. Okay, has been dropped. Then this one, job ID. This one is used in the job history. We deleted the job history first, so now I think it's possible to be deleted. Then don't delete the system. This one are system tables. Okay, don't delete them. So here, if let's say we want to delete the countries. Okay, what's about employee? So all of the other tables are system tables. Okay, don't delete them. Then after this, now we should be able to run our scheme. Yeah, our scheme actually is available in the software here. I put it. Scripts here. This is the HR. They call it the human resources database. And this one is the modified one for Oracle, because last time the coordinator gives us the hr.sql, but after that I realized there's many errors, so I modified in this HR Oracle, and also I created another one for MySQL. So let us now start the HR Oracle. Okay, let us open this. Well, it's this one. Okay, this script actually is created to build the entire structure of our database. So it will start with create a table of regions, then it will create the indexes and also constraints like primary key and so on. Then it will go and create the table of countries, also the primary keys, constraints, and everything related to that. Also, sometimes you see alter table countries, constraint, blah, 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 foreign key. Yeah. So this is to add the foreign key. And after that, we create the table locations and we create the constraints and everything, unique indexes, also primary key, foreign key, and so on until we finish. So here we create the location sequence and also departments, department ID, primary key. This one departments table has been altered here to insert foreign keys and primary keys. And after that, we have department sequence created here. So create sequence here. This sequence actually is to give an automatic sequence for every department created. Okay, so the department ID will be automatically inserted. As you can see, it will start with 280. It will increment by 10. So the maximum value for the department ID is 9990. Okay, this could be manually done like this using command, and also could be created using the wizard. Okay. Then after that, we create the job table, we create the employee table, we create department table or alter the department table. Then here we created the job history, and here we created a view. So the view is another thing. The view is not table. Okay. The view could be a result of multiple queries or a complicated query. Okay. Later we will see how to create views. Then here we start, after we commit the structure of data, we start. Okay, what line is this? Line 252. Okay, the commit is line 252. Now I'm going to run the first part of this query. Okay, of this script. Actually, this script, when we want to run the script, actually we should click on run script, so everything in the file will be run. Okay, but if let's say we want to select some part and we want to run it, in this case we have to run statement. Okay, so here we click run statement, we selected my local database, we try to run. So everything is completed. Okay, let us now here come and refresh. We can see here the countries, employees, departments, job history, jobs, location, and also here we can find what they call it, regions, and so on. So all tables have been created, right? But these tables are empty. Those tables are empty. I did a mistake. I closed the query. I have to find it again. Okay. We run until line 252, right? Until line 252. So we run until here, until this commit 252. Okay. So now we need to run other things. Here station set in a list language American. Also they changed the station set language. Okay. And after that, they start seeding the data inside our tables. So if you go and run select star from regions, you are going to get nothing, right? Select star from regions. Let us run. Where is the select star from regions? So if we run, oops, it has some data, right? So it looks like the entire table have the entire what they call it script has been run. Okay, what's about department? Departments? Nothing, right? Okay, it seems that we didn't delete regions, right? We forgot to delete table regions. That's why data is still there in the regions. Or maybe there are regions added here. I don't think. Yeah, regions are added here. Okay. Okay, for that reason, we have to delete from regions. Is it delete from? Delete from table. Mentions like this. Okay, for rows deleted. And here for the departments, we don't have anything. We want to check whether we have data or not, because if we have data and we inserted data with the same primary keys and everything, then it will give us some errors. So here, jobs. Nothing in the jobs. Job history. History also has nothing, supposed to have nothing. Entries. We shouldn't do that actually, but because we had the database first and we deleted, I'm afraid that we missed some tables without deleting them, that which will cause an error. So now we are going to insert the data. As you can see here, we are going to seed the data by inserting some regions in the regions table and some countries in the countries table, and after that we will insert some locations in the locations table, and as you can see here, we will insert some departments, and after that we will insert some jobs and some job history for some employees, some job histories, and so on. Okay, so you can see here all of them. It's a very huge database actually. That's why I'm not going to browse it all. Okay, we will start here. We stopped here. We ran until here last time, right? So now we will start from here and we will go until the end of the script. So here, if you can see, after we inserted everything, we enabled, after that, we enabled our constraints. Okay, because we disabled them at the beginning because we don't want to have any issue because of the constraints. Okay, that's why after that, after we finished, we enabled them. Okay, so here we are. After this, after we enabled the constraints, we created what they call it here, procedure, storage procedure, which is here rem procedure and statement trigger to allow DMLs during business hours. So here we create or replace procedure. We created this procedure, stored procedure, and also we created or replaced this trigger, secure employees, and also we modified the secure employees. We modified that, and we created another procedure called add job history, and also we created another procedure or another trigger called update job history. Okay, so the trigger actually could work only when we have some events. Okay, later we will explain how it works, because until now we didn't take the triggers and we didn't take the stored procedures as well. Okay, so for now I'm not going to explain this. I'm only going to run. As you can see here, one row inserted, and so on. So as you can see, the commands, commit complete, everything was run smoothly. Okay, so now after we close this, we could run like this. And see how many countries do we have in the database. Okay, so now we have the environment to build our database, our HR database. Okay, so I am going to share this with you through the WhatsApp for now to make it fast, and later maybe I will give it to you by the or through the Bootstrap Plus. Okay, so please, if you want to run this, open it and press on the run script. don't press on the first button. So you can run it at one shot, as one shot, one time script. Okay. So you run everything. Don't click twice, because if you click the second time, then it will show you many errors because you want to create tables that has been exists. Okay. Easily you can go and run it. Then you can play with the commands. Okay, let us go now through the what they call it here. The lab practices. So the lab practice here, one, I think it's the same. That shows the structure. I already shown this to you before. Then we have lab practice 2. Okay, for lab practice 2 here, we can see the create command, how to create table for customers, for example. So this is to show you how to create the table, then how to insert the records into the table, and how to update the customers, how to change the value of the address to this where the ID is equal to 1 and so on. Okay, so for this lab practice, I'm going to give you the file and I want you to follow step by step. Okay, I want you to follow it step by step. Okay, this one is lab practice 1. And this one is lab practice 2. And let us open the lab practice 3. Okay. Here, in this case, here we have, we will go through these queries because these queries could be run based on the HR database. Okay. So here, the first one, the HR department needs to find information about an employee with last name this, Hygiene. Okay. Display the full name, department ID, and the salary of the particular employee. Okay, let us take this. I'm not going to copy the command. I just want to copy this. Oops. Copy. Okay, save this. So this is the requirements, right? Let us start. The HR department needs to find information about employees. So what we need to do is to select what? Full name, department ID, and salary. Okay. So here what we have here from the employees. What do we have? We have first name and last name. So how to concatenate them? To create the full name, we have to use first name. Then we have to use this, and after that we put space, then after that another concatenate, and last name, like this. So this will retrieve the full name, right? And here we could say as full name, right? Because this name, Elias name, has a space, we have to put it in between two double quotations. Okay. So this is the first column. The second column is the department ID. Department ID is available directly. So department underscore ID. Okay. Then what else we have? Salary. Okay. From what? Here, from employees. Okay. So that's all. This is the command. This is the first requirement. Okay, let us run. It shows everybody from the employees. But here the HR department wants only to retrieve the person or the people whose last name is equal to Hygiene. Okay, let us copy that. And here we write where last name is equal to like this and semicolon. Okay, so this is the condition. Let us run. Okay, here we are. Okay, that's great, right? Very easy. But if you see here, they use the concatenate function here, right? They use the concatenate function. It's the same way actually. It is the same thing, but this one is a little bit complicated. Instead of using this, you see, instead of using this, we use the concatenate. And here we use nested function, nested concatenate function, because at the first, we need to concatenate the first name with the space. Then after that, we concatenate the first name with the space and the last name. Okay? So you see it's even longer, right? That's why I don't want to use it. Normally, we use this easy concatenate operators. Less complication, right? Is that clear, guys?
Yeah.
Okay.
Yes.
Yeah. What's about the second requirement? In the second point, because of budget issue, the HR department needs a report that displays the last name and salary of employees who earn more than 10,000. Okay, let us copy this. Let's go here. Delete that one. We put this one. Of employees who earn, okay, like this. So what we want to show here, they want us to show the last name and salary only. Okay, so we keep the last name. We remove this. We remove the department ID. We keep the salary from employees who earn more than 10,000. So in this case, we are going to compare their salary. Okay, if their salary is more than 10,000, right? So here we get the result of 15 people. Okay, so those people here are going to be targeted for salary reduction. Okay, is that hard, guys? Simple, right? Oh. I think everybody is sleeping in my class. Are you sleeping?
No, doctor.
Okay,
No.
so is it clear or not? This one.
Easy.
Yeah,
Clear,
very
clear.
easy, right? Okay, so do you want to continue these things with yourself?
Yes. Maybe we could try.
You try, and if you have any issue, just let me know before tomorrow, okay? So I will send this to you. Here, practice. Okay. Or yeah, this one. Let us go through quickly to find the complicated scenarios only. So in here, create a report that displays the last name and department number for employee number 201. Very easy, direct. Here, the HR department needs to find high salary and low salary employee. Employees display the last name and salary for any employee whose salary is not in the range of 5,000 to 12,000. So this one is directly can be run. So we use the between 5,000 and 12,000. Here in number 5, create a report to display the last name, job ID, and start date for the employees with the last names of Matus and Taylor. So here we will use where condition where the last name is equal to Matus or last name is equal to Taylor. Or also we can use in, right? We can say where last name in and we open braces and we put Matus, comma, Taylor. Okay? Then they ask you to order the query in ascending order by start date. Okay, so you will use order by higher date descending. Here, display the last name, department number of all employees in department 20 and 50. Very simple. Display the last name and salary of employees who earn between 5,000 12,000. Very easy, where salary is between 5,000 and 12,000, and are in department 20 or 50. So here we can use and department ID is in 20 and 50 group. Okay. Label the column employee and monthly salary respectively. So as you can see here, last name is renamed as name, salary is renamed as monthly salary. Display the full name, job title, and salary of employees whose salary starts with 170. Select concat, blah, blah, blah. So they show the columns here. Then after that, they join with the jobs. Okay, this is quite complicated. Okay, let me take this and exercise myself. Okay, so here, display the full name. Job, full name is not an issue, so that's why I am not going to do concatenate blah blah blah. It's not an issue. First underscore name, or even if you want to make it, it's very easy as I mentioned. Then here, oh, oops, concatenate like this, space, like that, and another concatenate. So here we can say as full name. Then what they want, job title. Job title actually is not available here. Job title is not available in the employee table, right? Here we have only the job ID. So what to do now here is to go and join jobs on. Here for employee we are going to use E, alias name, and for the job we are going to use J as alias name. So here when E dot job ID, job underscore ID is equal to J dot job ID. Is it job ID here? Yes. Job underscore ID. Okay, so here what they want the job title, salary of employees. Okay, let us take the job title here. Job title actually is going to be retrieved from J dot job title, job underscore title. Okay, this salary is retrieved from the E, from the employee. Also last name is retrieved from the employee. First name is retrieved from the employee. Okay, so here we are, where whose salary starts with 170. Okay, now just forget about this. Let us run this first and see how it works. Yes, okay, here we are. The result is retrieved correctly. Okay, then now let us check where salary is what to use here to fulfill or to satisfy this condition. What kind of condition we are going to use here? Guys, how we can retrieve salaries that starts with 170? Nobody is here?
Is it more than 170? More than
No. More than 170, it could be 171, 172. So there is no zero there, right?
Yeah.
Yeah, what to do now?
Can we make more equal?
You want to say like this. More than or equal like this,
more than
right?
it.
More than or equal 170 and less than and salary less than like this, less than 170 171, right? Is it? Or
I'm
maybe
not sure.
1700 like this. Is it? All of this is not going to work. All of this is going to retrieve you rubbish result. Okay? So what you are going to use is like. Okay? You forget this, right? So
Yeah.
how we can use like? So we can say 170, then percentage, right? So anything that has 170 at the beginning, the result will include salaries like 170, 1,700, 17,000, 170,000. All of these results are going to be retrieved. Okay? But if you go and check that, if you want to check by greater than or equal, less than or blah blah blah, you need like 1 meter of code to finish the condition. You understand what I mean?
Yes.
Yeah. Okay. So here we retrieve only 2 people who has their salaries starting with 170. Okay. Easy, right? Okay. It's you see here. It's totally wrong. This one. Totally wrong. I don't know why they wrote it this way, but honestly, it's totally wrong. Okay, guys, please fix it in your file. Okay, lab practice 3. Just fix it. Go and fix it. 170. Because if you keep it like that, then it will retrieve you all salaries that has the second digit in their salary equal to 7. It could retrieve the same result, but it's not correct. It's not correct condition. Depends on what kind of salaries do we have. You see here, the result is totally different. What we need is only these 2 guys. But based on this condition, we retrieved all salaries that has number 7 at the middle. Okay, number 777. So anything has number 7, it's going to be retrieved. Okay, if we want to say that we need to retrieve the salaries that has the second digit as number 7, then whatever after that we can use underscore like this. So here it will retrieve only the salaries that has their second digit from the left side is equal to 7. Okay, so don't forget it. Like is very good operator to use, especially when we have conditions that works based on patterns. Okay. For example, if let's say we want the second digit to be 7 and the third is anything, the fourth should be, for example, 1. Okay, because we don't have salaries that have the second digit is 7 and fourth digit is 1. That's why it's going to retrieve nothing. Okay, nobody. But if we make it 0, it will retrieve number of staff. Okay, so here it retrieves every salary that has the second digit from the left equal to 7 and the fourth digit equal to 0, and whatever digits after that is not matter. Okay. So this one, please go and correct it. 107. Okay. The number 9, the HR department needs a report. that displays the last name and hire date for all employees who were hired in 1994. In 1994. So here, what you are going to do here, okay, let us copy this. Copy the requirements first. Okay, display the last name and hire date. So last name and hire date. The last name, I am going to show the first and last. I don't want to change them. No problem. Just keep it like that because we don't have join anymore for this question. We are going to remove the, what they call it, like this. Okay, they need the hire date, hire underscore date for all employees, and salary is not required from employees where hire date is equal to 1994. Actually, this one we are not sure about the hire date. Hire date, is it date field or hire date? Hire date, it's date. So here, if this is a date field, so what do you have to do actually is to take the year from hire date, okay? Because what we want to do is to compare the year with the 1994, okay? So we are going to use this command. Actually, this one is a function instead of hire date. So this function will extract the year from hire date, because hire date is date. Then this function will be able to find the year from this field. But if this field is string, for example, this function is not going to be working, okay? So this function here actually is, how can I explain? I will show you how it works first. I will put it here in the select clause, and I will exclude the where clause here to show everybody. Okay, so you can see here from the hire date here, it's 17 June 87. It extracted this one. This function extracts the year only. Okay, so everything is here in 4 digits format. Okay, so after that, this year actually is compared to 1994. Okay, so let us delete this here and compare it to see only people who are hired in 1994. Okay, is that clear, guys? This one is a very useful function. Okay, I will show you other things actually, huh? You see this one could extract year, and also we could extract month, and also we could extract day. Okay, so let us see here. Let us run this part only without the where clause. Okay, see here, 17 June, this one 17, and this is June 1987. Okay, this is how to extract information from your date field. Okay, is that hard, guys, or easy?
Not hard.
Not hard, right? Yeah, very simple. But the only thing you need is to memorize the available functions in order to write easily your queries. Otherwise, if you forget, like now, when you forget the like, you will make your life miserable. Okay, when you forget the like operator, you start thinking about how to create a condition to use greater than or equal, less than or equal, and you make a very complicated condition, right? But using like operator is very simple. We can make it. Also, using the extract is very simple. Otherwise, if you forget to use the extract function, then you have to go to the higher date, and after that change it to the string, then after that go and substring from that string. So you will use many functions to get back the year only. Okay, so always you have to remember the available function. Okay, let us see number 10. Create a report to display the last name and job title of all employees who don't have a manager. Okay, so this one this one actually is join, so that's why I will do Control Z to retrieve our join command. Okay, because here create a report to display the last name and the job title. Job title actually is not in the employee table. Here we have only job ID. That's why we have to use the join command, right? So here what we want to show the last name and the job title. So instead of this, we need the job title like that, and instead of the last name, I'm going to show the full name, and for employees who don't have a manager. Okay, so the manager here like this, we could check like manager ID is null. Okay, because this one, if you go and see here, manager ID could be null, right? Otherwise it must be a number, so it we shouldn't go and check whether it's 0 or not. Also, we shouldn't go and check whether it's empty space or not, because empty space is not acceptable. Empty space cannot be saved in number. And also zero value, it could be saved, but in only one case. It could be saved only if there is an employee, his ID is 0. So in that case, that 0 employee could be a manager for other employees. Okay? But if there is nobody with the employee ID equal to 0, then the 0 value is not valid for the manager ID. So the only thing we need to check is the null value. So here we can say is not null. What's the required here? Don't have a manager. Don't have a manager means they don't have a manager. So when an employee has no manager, the value of the manager ID will become null. Okay, so here we see only Stephen King, which is the president. Okay, only Stephen King. Stephen King is the highest employee. Okay, let us see his employee ID underscore ID, comma, then here his ID is 100. So if we run this without the where clause to show all, so this is the top employee. Okay, this has the lowest employee ID, which means it's the first employee keyed into the system. Okay, so all of other people has employees, has manager IDs. So if let's say manager underscore ID like this one is coming from E. So we will see, oh sorry, we need to select this. We will see only this guy has no manager. Other guys, other employees, all of them has managers, right? So that's all about it, about number 10. Let us go through number 11. Create a report to display the last name, salary, commission of all employees who earn commissions. Sort data from blah blah blah. Okay, this query is direct query. I'm not going to explain. Display all employee last names in which the third letter of the name is letter A. Select last name from employee, where in string. This one is to use the in string function. Okay, I'm going to copy this to explain to you how it works. Okay, this one is to show the last name for employees who have in the third place of their last name, in the third place, they have letter A. Okay, so how we can make it? So we have to check whether in the last name whether we have letter A at the place number 3 or not. This number 1 means the first appearance, because in some names we have multiple appearance of A. For example, let us take for example give me a name with the third letter equal to A. For example, Khalid. Okay, so here the first appearance to letter A actually is the third place, right? So here this function will check if the third place is the first appearance of letter A or not. Okay, so if this one is valid, I mean if this condition is valid, then this function will retrieve number 3. So that means number 3 has the first appearance of letter A. So it will be equal to 3, then the name will be displayed. But if let's say we have, for example, Ahmed, okay? So the first appearance of letter A actually is going to be equal to 1, right? So 1 equal to 3 is not true. This name is not going to be retrieved. Okay? If we change this to 2, then the second appearance to the letter A actually is number 4. So 4 equal to 3 is not true. Also is not going to be retrieved, right? So this is how it works. Okay. Display the last names of all employees who have both an A and E in their last name. Select last name from employee where this one last name has letter A in it, in any place. Okay, if it has the letter A in any place, it's going to show the index of the letter. So if the letter A is at the first or is the first letter in the name, so it's going to retrieve number 1. If let's say letter A appears at the second place at the name, then it will show 2. So in all cases, if the letter A is available in the name, it will show numbers that's greater than 0. So that's why we used greater than 0. So if the name has letter A in it, in any place, it's going to make this condition true. Also, we want to check the letter E as well. So here, if the name has letter E, it's also going to retrieve value greater than 0. So this condition also is going to be true. And because this one, we need to have names with letter A and letter E together. So that's why we use AND operator here. Okay? So let us go here and run. So you see all names that has A and E in their last name. Okay, no matter in what place. Because here we didn't mention. Because this one in string function, it could be like this or like this. Because it has many overrides, many versions of the function. One version is to have the original string. Then we have the string that we want to check it inside the original string. And also we can decide the position. And also we can decide the number of appearance. Okay? So it could be run in many versions. So here, because we used AND, we only retrieve names that has A and E. But if we use OR, it will show names that has A only, or that has E only, or that has A and E together. Okay, so here in the previous one, when we use and, we retrieve only 17 names, but now we are going to retrieve more than that, so we can see 82. So here in this name we have E only, here we have A and E, here we have E only, here A only, A only, E only, and so on. Okay. 14, here display the last name, job, salary for all employees whose job are either sales representative or stock clerk, and whose salaries are not equal to 2,500 and 3,500 or 7,000. So here we have multiple conditions. Okay, here we have select last name, job title, salary from employees. Then we have left join. Okay, left join with jobs on. Because why we need left join? Because we don't want jobs that has no employees. Okay, we want only the employees who are involved in this kind of jobs, sales representative and stock clerk. That's why we need to use left join. Okay, then let us copy this and see what is the difference between left join and normal join. Okay, left join, as I mentioned, is what they call it outer join, but join only means inner join. Inner join means the intersection between the two tables. Okay, so here, if let's say this is the condition, as you can see here, we have 43 employees, and all of them has values, has job title, right? But if let's say, okay, 43, right? If let's say we remove this and we run, still 43, right? Because the database actually is in a consistency mode. So we have maybe we don't have jobs that's not used. Okay, let us check. If let's say we want to use right join like this, so the result is going to be also the same. That means there is no job in the database which is not used for any employee. So any job available in the database is already used by some employees. And also, no employee in the database has no job. That's why in all cases we got the same result. In all cases, we got the same result. So here, what if we use full join? It's going to show the same result. Why? Because the data, as I mentioned, is consistent. There are no jobs saved in the database that's not used by employees. And also, there is no employee without job. But if we have one employee without job, or one job that's not used for any employee, in that case, the result will be different between the right and left and full, and also inner join. Okay. I'm not sure whether the job ID is nullable or not, but let us try. Let us try. If the job ID is nullable, then I'm going to create an. You see now, I want you to stay with me, right? So here we use join only, like this, which is inner join. It gives us how many records? 43. Also, we used full outer join. It gives us also 43. Left gives us 43, right? So all of them, they give the same result. Okay, right? It gives the same result, 43. Okay, but if we insert into employees, right? Set values are equal to, like this. So we need to see select star from employees first. We need to see the number of employees. So here the last employee is 2,600. Sorry, 206. Okay, let me copy one record from here and let me put it like that. So here we put this one 27. This one is like this, William. Sorry, this one is single, comma. This one is like this. Make sure that you don't have special characters here, okay? As I mentioned always. Then it's this one is email, and this one is phone number. Phone number is a string also, and this one is date. Account, AC account. AC account is what? Where is it? Job ID is bar chart. Okay, so also this one like that, and after that this one is salary. Salary is going to be a number. Also this one is manager ID is a number, and department ID is a number. Okay, if job ID, this one we put null here. Okay, let us run this and see how it works. For rows deleted. Why? Column 14. Column 13. Okay, not enough values. How? Not enough values. Let us check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we still have commission. Commission is null, right? Okay, null. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's supposed to be correct now. Okay, now we will have a problem. Column 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Employees. Is it true? I don't know. This one date. Where is it? Date. Not malleable. Cannot insert null into job ID, you see. This misleads us. Okay, job ID here is nullable, but at the same time, oh, default value is null, but it doesn't accept null value. Okay, okay, that's why we need to fill up. Okay, that's why we cannot modify this unless we go to the table and edit that table. How we can edit? Oops. Yes, this one, edit. So here I'm going to stop the constraint here of the job ID, I will make it nullable. Okay, then here we are. We can now insert null value to the value larger than specific precision. La ilaha illallah. This is an issue, you know. That's why sometimes when you deal with something that you don't create, you don't know the exact constraints they create and everything. That's why it's going to be an issue. Okay, let us open the query first. Control F, insert into employee. Yes.
We have other class.
You have other class. Okay, you can move immediately. Don't worry. I'm going to finish this first. Then after that, I'm going to enter class. Okay. So if you want to move out, you can move. Don't
Sorry,
worry
Doctor.
about it. Yeah, because I'm recording the video, I need to complete it. Okay?
Okay, Doctor. Thank you. You will upload
Yeah.
today, Doctor?
Sorry?
You will upload the video today?
I'm not sure. Actually, I'm very busy nowadays, having a lot of thesis to read and many issues. That's why I'm a little bit slow. And also sometimes I have time and the system is not working. You see, the error is toDate function. We forgot to use the toDate function. That's why it shows an error. Anyway. Okay, job ID is we need the job ID here as null. So let us now insert. Still have an error. Email UK. Oh, where is the email? Email is here. One, two, three, four. So the fourth one is the email. 1, 2, 3, 4. So here at email.co.uk. Okay, one row is inserted because here the email is also need to be checked to be a UK email. Okay, so now the row is already inserted. So here, if we come back to our query, the one that we used here. So at the beginning, when we change right join, left join, full join, or inner join, all of them has shown the same result. So okay, let us show the left join now. So in the left join here, we are going to retrieve multiple records, right? Which is 43. So every what they call it, every employee from the left side, no matter he has a job title or not. Let us remove this, because here in this condition we mentioned the job title. So that's why all results will be the same. Okay, let us remove that. So we see run. So here the result shows 98, right? 98 results. But if we make it inner join, it will exclude this, right? So it will become 97, for example. So 97, right? What if we make it right? If we make it right, is also is going to show different results. What is this? Command not properly indented. Right jobs on. Right join. Sorry. Okay, here it retrieves 97 as well. And if we show full, here it will show 98. Okay, so here the results are different, depends on what kind of join we use. Okay, so sometimes the condition you used here, it guarantees that all types of join will retrieve the same result, the same number of records. Okay, that's all for today. Inshallah, we stopped on this one. On 14, I need you to go through all the other practices here until 18 in the lab practice 3, and also I need you to go through the lab practice 2 and so on. Okay, hopefully everything inshallah will be okay. If you have any problem with the practices or any command you cannot understand or anything you cannot answer, just let me know. Okay, inshallah. See you. Thank you for attending my class. Assalamu alaikum wa rahmatullah.